Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enroll in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which is really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident, and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that, and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them very all the best, and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us, and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot and I experienced a lot of things today. So I'm really hope to be placed in that company. I'm confident about that. Thank you.
This was my first association with XLR. I had got a call from Miss Shubha and we fixed a drive here. Today when we came here, I was not expecting much, but the hospitality was too good, staff is quite cooperative, and it's like a happy-go-lucky kind of a environment here when it comes to XLR people. When it comes to candidates, yeah, we have got few candidates and they are all agreeing to all our terms and conditions, and I hope they join the organization and work for us, and I'm expecting long-term association with XLR people, with more recruitments or more collaborations with them.
XLR has been a good partner for us because we found some of the candidates were excellent, and we wanted people.
Yeah, so good evening, students. So we'll wait for maybe some time for others to join, and then we'll start the session. Today's topic will be graph in DSA. So it's one of the tricky topics. So let's wait for some time for others to join, and then we'll start the session. Fine, so seems like there's very less number of attendance today, but we'll start the session. So let's come to our topic. And here we'll go with some theory part before we go for the practicals. We have already completed the tree part. Now we are going with the graph part. So now a graph in DSA is a non-linear data structure used to represent relationships here between pair of objects. It is used to show the relationship between the pair of objects. It consists of a finite set of vertices that we call node, and a set of edges that we call links. So every tree is a graph, but every graph is not a tree. That connect these vertices. Right? Graphs are highly versatile. And used to make models of real world networks. It's networks. These networks are social media, like your friend as a friend. So it's your third contact list or second contact list, roadmaps. And the internet, World Wide Web. So this is the use case of graph. Good evening. So now key terminologies and types. So vertex, so a node representing an entity. So basically it can be a city, a web page, anything. So that is called a vertex in graph topology. Edge. This can be a connection between two vertices representing a relationship. Now we have weighted graph. It's a graph where edges have associated numerical values. They are called weights. It can be representing distance, or cost, or even time. These are called weighted graphs. Directed graphs. Now there is another type. Now graph has a bit of theory also. That's the reason we are going behind it. Push-as algorithm, depth first search, breadth first search. They are all types of it, and we'll see today only this. Now diagraph. So it's a graph where edges have a specific direction. Maybe they are going upward, downward, one-way street. Example can be a one-way street. undirected graph, so now it's a graph where edges are bidirectional. Now example can be a two-way street. Or a friendship on social media. So window show. And then we have a cycle. A path in graph that starts and ends at the same vertex. So now these are the key terminologies. Anyone any idea in this? Or any doubts in this I should say? You can read it, you will get an idea. Again, we'll be doing questions on the basis of this. So please go through it. A graph is a non-linear data structure used to represent relationships between pair of objects. It consists of a finite set of vertices, nodes, and a set of edges links that connect these vertices. Graphs are highly versatile and used to model real-world networks like social media, road maps, and the internet. Key terminology: vertex, a node representing an entity. Example, a city or a web page. Edge, a connection between two vertices representing a relationship. Weighted graph, a graph where edges have associated numerical values representing distance, cost, or time. Directed graph, digraph, a graph where edges have a specific direction. Example, a one-way street. Unidirected, of course, it will have two directions. So, a two-way street. And cycle, a path in graph that starts and ends at the same vertex. So now here we come to the next part. So anyone any doubts in this? Any doubts in theory? So now when it comes to Java, what is our use? Because Java does not have anything inbuilt for graph. So representation in Java. How can we do it in Java? So now since we are doing it in Java, not in C, P or Python, so we should be more concerned. Java does not have built-in graph classes. Excel? No, we are doing with the DSA questions. This is our third week. Marleki. We are doing for XLR, but not Microsoft Excel. So Java does not have. Oops. Built-in graph class. Like you have link, you have list, set, tuple in Python. Here you have link list, array list, and then hash map, link hash map. But there's nothing for graph. So developers must must implement. That's the reason why it's a bit hard for students using standard collections. The two main I should say the two primary, not main, ways to represent a graph in memory are: first one, adjacency, matrix, ED. And the second one is adjacency list. So these are the two ways wherein we can do. So now we'll go with the definition of these two so that we get a better idea. It's a 2D array, two-dimensional array where matrix, that is array of I and array of j. You have seen this, stores A1 or the weight. What is the weight? We have already seen on top, weighted graph. Fine. Or the weight. So if an edge exists between vertex I and vertex j, I'll write it small only. And 0 otherwise. If not this, then it's 0 otherwise. This is suitable for dense graphs. Where you have many edges. Again, when we'll go with the question, you will get an idea. But can be memory intensive. First pass graph. When your graph is not very dense, it can be memory intensive. So you have adjacency matrix and then you have adjacency list. An array or hash map where each vertex stores a list. It can be a linked list, hash set. Now depends, if you don't want duplicate, you go with the hash set, you want to maintain the order of insertion. Or you can have linked list wherein your travel cell is time taking, but removing or adding elements is O of 1. It's very fast, we have seen that. Or it's adjacent. vertices. This is generally more memory efficient. For real world sparse graph. So if you have a dense graph, you go with the adjacency matrix. Or else, if you have a sparse graph where you don't have a lot of edges and nodes, you go with adjacency list. And is commonly used in Java applications. Fine. So now we'll go with the common graph algorithms. First, you can read till here, and then, of course, after this, we'll go with some practical parts. But unless you don't know the theory, believe me, you'll always be confused about practicals. First, your key terminologies, what is a graph, what key terminologies, and then representation of graph. So now, common graph algorithms. Various algorithms are used to traverse graphs and solve problems. So we use various. First is BFS. Maybe we can name it breadth. To name it, first we can name this one breadth first search. So this one will see only the same line first, and then it will go deeper. It will not go to the depth. First, it will go with the breadth only. Explore the graph level by level. So we'll be at the same level where we saw a tree, using a queue to manage visited nodes. It is used to find the shortest path in an unweighted graph. So you have breadth first search, depth first search, wherein you go to the depth of first node, then you check the second node. So we call it DFS. It explores a graph by going as deep as possible along a path before backtracking. Now, everybody knows what is backtracking. Are you aware of backtracking? Fine. So backtracking is a concept wherein like you have nodes. Okay, let me show the tree diagram only to you. Thanks for telling no. So if I show you, okay. Okay, 1 minute. Let's open paint only. So you get an idea. So what is backtracking? Again, I'll explain it to you and we'll go with it. So basically we have seen tree and all. So is the screen visible? Is the paint visible? Okay, 1 minute. Yeah, I guess it's visible. So wherein you do tree traversal, you move from one element to another, another to another. So it is binary search tree. Each child will have, for example, 2 sub-children. So we'll keep this simple. So now maybe we'll have numbers here. So at the top we have 5. So this one would be lower than 5. It can be 4. And this one will be higher than 5. So it can be 9. Okay, fine. So again, here we come. And then this one would be 2. And this one can be 8. Fine. And this one can be 7. And this one can be 11. So basically what happens in backtracking is first you come from year to year. Okay, these are connected. Rat in a maze is an example of backtracking. Wherein what happens in now here in backtracking, what happens is, yeah, fine. So you from here, you come here in travel cell. Okay. So in breadth first search, what you do is you search all the nodes at same level. So it is called breadth first search. BFS. Okay, sorry, yeah, F. Yes. Is BFS concept clear? What is BFS? Of course, DFS, BFS, and then we'll go with the backtracking. BFS is clear. Breadth first search means, yeah, okay, Jatush, thank you. What about others? So that is your breadth first search. Again, in depth first search, what happened? Oh, okay. Again, in depth first search, first let me erase it. Again, in depth first search, what happens is, first you go here, then you go here, then you see, okay, you cannot go anywhere, okay, fine. So then, of course, from here you come here. So that is depth first search. First you see this entire part. So that is called depth first search. Is DFS clear? Depth first search is clear. What is DFS? You go till the depth. Fine. And now backtracking is where from here 5 you go to 4, from 4 you go to 2. Again, if you have any element below 2, maybe here you have one more element 1. So what you do is you come to 1 here and you go as deep as you can go. So here you go. So maybe from here you try. Okay, 1 more. You do travel, so you from 5 you come to 4, from 4 you come to 2, from 2 you come to 1. And then from 1 you cannot do anything. So again you go back to 2, you go back to 4. Because from 2 also there are no branches. If there are branches, again you come here. Again you'll go, you'll come, you'll go, you'll come. So that is called backtracking. You go to the last, you go till last. And then of course, if you don't have any option, then you take a U-turn. And then again you go to the last. So that is called backtracking. Is backtracking understood now, students? What is backtracking? That is backtracking in DSA. Anyone is having still any doubts, you can ask me. So, thank you, Sania. So, we do backtracking as well. So, depth first search is there, breadth first search is there. So, basically, we do it typically using a stack. Stack is what is the rule of stack? Last in, first out, LIFO, or recursion. Recursion means you call something again and again, wherein you get the result or you go out of the memory. Or maybe you don't meet a condition, you go in an unending loop, something happens. So now DJ Krishi's algorithm. So it finds the shortest path from a single source vertex to all other vertices in a weighted graph with non-negative edge weights. Then you have topological sort. And again, don't worry if you feel like it's very confusing. Once you start solving questions, you will automatically solve the question and then you'll understand, okay, this was this. Like, it's not very hard, to be honest. Linearly orders vertices in a directed acyclic graph. That is again called DAG, directed acyclic graph, such that for every directed edge from vertex U to vertex V, U comes before V, of course. In the ordering. So again, we have last topological sort is done. So Prim's and Kruskal's algorithm. You can read this and then we'll go with that. Take some time to read this because this is again important theory. Prim's and Kruskal's algorithm. Now the last one is, and then this is the last thing, okay? It's Kruskal's, I believe. So basically here it is used to find the minimum spanning tree, MST, of a weighted graph. So this is your theory, and I believe that's it for theory. Now we are already too much into theory, and we'll be doing some practical now. So you can just keep these terms in your mind. So these are the core, heart, and key concepts of graph. Inside the graph also you can see you have many more things. Just read through it once, and then we'll start the question solving maybe in next 5 minutes. So now let's try to go ahead and see some questions. So here we come, and maybe graph in Java. Right? So here we come, and of course there are many adjacency metrics and adjacency list, and we have already done this type of theory. So now here we come with the question. Okay. So first we'll go with simple graph questions. So here we have. So here we get some questions. Again, you can see you have medium and hard, only this range. There is no easy question here. So now here you can see the difficulty level. Let's try to see one medium question and try to see can we solve it or not. So clone graph. Given a reference of a node in a connected undirected graph, return a deep copy clone of the graph. Each node in the graph contains a value int and a list node of its neighbor, class node, public int value, public int. Okay. So now test case format. For simplicity, each node's value is the same as the node's index. One index, it's not zero index. For example, the first node with val 1 and the second node with val 2 and so on. The graph is represented in the test case using an adjacency list. You can see here, you have adjacency matrix and adjacency list. And adjacency list is the collection of unordered lists used to represent a finite graph. Means it's not an infinite graph, it's a finite graph. So the given node will always be the first node with val A. So this is question number 133 and maybe I need to log in. So now it's question number 133. Here you can see the explanation is given. Adjacency list is 2, 4 here, 1, 3 here, 2, 4 here and 1, 3 here. Output is 2, 4, 1, 3, 2, 4, 1, 3. Explanation, there are 4 nodes in the graph. So here you can see this is the graph. It has 4 nodes. So first node value 1's neighbor are second node's value 2. So first node is having second node 2 as neighbor. This looks like a clone. The nodes are new. Graph looks the same. Neighbors are first node value 1 to 1. So here you have 1, here you have 2, here you have 1. So now these are your questions. It's question number 133. Please try to solve it. If not, we'll do it together. But at least give it a shot. So I give you 5 minutes to solve it, and then of course you can tell me if it looks too hard and intimidating. We can go with the easy and medium questions, because in graph you have all medium and hard questions only. There is no easy question in the graph, as per my observation. Try to solve it. If not, we'll do it together, maybe at 8 o'clock. Okay, so now let's try to do it together. Yeah, Firdaus, good. I guess Firdaus' approach will also work. He has taken graph, fine. Node is equals to null, fine. Welcome, ma'am. So now let me also try it. Now First, let's make a variable. We call it map. It has key value pairs, so I'll call it node. I'll make it. It will be node only. Because map has key value pairs, I'll call it map only is equals to new hash map sequence of orders stored. So now, public class clone node, yeah, of course, node is there. So now here we come and tell if node is equals to null. At that time, what you do, you return null. Again, I am also not very sure my answer will completely clean all the test cases or not, pass, but at least try. So, if already cloned, if we have already cloned it here, you can see it's asking for a clone. Original, and then this looks like a clone, like original's clone. So if already cloned, at that time what you do is, if map dot contains key, again if you find this one hard, I would request you to go with your collections framework and revise collections thoroughly. At that time what you do is, you just return map dot get method and then get the node. If already cloned, do this. You just see the contains key, clone current node. Of course, if it's already cloned, no need to clone it. But then if it's not cloned, then you call it node data type. Clone is equals to new node, create an object, and call it node dot value. You get the value of the node. And then you do map dot put it, and then node comma clone. You have node as well as the clone value. Semicolon compulsory, since it's Java and not JavaScript. And then you clone the neighbors. We have done the main cloning, and then we are cloning the neighbors. So we tell clone neighbors, and for enhance for loop node neighbors, node dot neighbors. At that time, clone dot neighbors dot add, and what we are going to add, clone graph neighbors. And I believe if I return the clone after doing it, let's try to run and see. Oh, okay. Spelling error. Neighbors. Okay, and it says there is a compile time error, and neighbors, clone neighbor. Okay. I guess this one should be in parentheses. So there should be couple of parentheses. Let's see. Okay. Again, we are stuck at the same place. Let's see what's the issue. I guess there's a solution. Semicolon. Okay. Yeah. See, it happens. Although it's very basic, but I did a mistake. Node neighbors, 1 minute. Okay, NEIGHB. I guess spelling error, I guess it should not be a big deal, but still. Since there are two versions, US version and UK version, and we follow UK version when it comes to our English, but when it comes to programming, we follow US version. So color, we write COLOR in programming, but in the schools we have studied COLOUR. So maybe that is the thing. I'm not really sure. Will this, I guess it should work. Let's try to see. Yeah, so now you see even spelling mistake was the case. It's passing the test cases. And now if somebody wants, they can take a screenshot of it. And then if I do a submit, I believe, of course, not very much fast, but then this one is working. So should we do another question on the basis of this, or 1 minute, what's there in the chat? Okay, you want me to dry run this with the test cases? 1 minute. So here we have test cases, case 1, case 2, edges, case 3. So here are your test cases. If you see the question. So here we do for dry run, I believe, like, where is the option here, Jatush? Are you aware of it? How can I do a dry run here? I know it in Eclipse, of course, in VS Code, but how do I do it here? Okay, fine. Theoretically explain. Okay, fine. Theoretically, sir, it's quite okay, simple. Okay. Let me show you. See the question here. If you go with the question. Okay, fine. Okay. Where is the question? Graph. Okay, here is the description, right? So basically, you are given a reference of a node in a connected undirected graph. So this one is connected but undirected. Like bidirectional means two directed. Undirected means it can go any direction. So you need to return a deep copy clone of the graph. So you need to have one graph, same copy, the other graph. You need to have a carbon copy of this one, very simple. So now, if you go here, network is telling each node in the graph contains a value integer and a list node on its neighbors. So it has a value and an integer. So these are your 1, 2, 3, 4 original values. And then this looks like a clone. The nodes are new graph look the same. So you have 1, 2, 3, 4. You can't return the same graph. Here also you can't return the same graph. So now here each node in the graph contains a value int and a list node on its neighbor. Find class node public int value and then public list node neighbors. So this is already given in your class node. Whenever we are telling a class node here, we have a value and then we have a list called neighbors. Again, this was my error. I was not doing the spelling correcting. So test case format is for simplicity. Each node's value is the same as the node's index. So you have index here 1, 2, 3, 4. These are your values. But then of course value is equals to 1. The first node, the second node value, because here index is also 1 based index. So 1 index 1 value, 2 index 2 value, 3 index 3 value, 4 index 4 value. So the graph is represented in the test case using an adjacency list. Now what is an adjacency list? If we go with the theory part, see, adjacency list, an array or hash map where each vertex stores the list, a linked list or a hash set of its adjacent vertexes. So whichever vertexes are adjacent to it, it will store it in that list. This is generally more memory efficient for real world. Sparse graph is commonly used in Java applications. So we don't go with the dense graph, sparse graph. Here you can see you have 4 values. So we use adjacency list here. So then an adjacency list is a collection of unordered lists used to represent a finite graph. Finite means a small graph. Infinite means you have n number of elements, like n is not countable. So each list describes the set of neighbors of a node in the graph. So the given node will always be the first node val is equals to 1. Here we are assigning value is equals to 1 and not checking. When we do double equals, we are checking it. You must return the copy of the given node as a reference to the clone graph. So here you have an example wherein you have original graph and this looks like you can't return the same graph. The node were cloned but the graph is messed up, doesn't have the same connection. So here you can see 1, 3, 2, 4. The edges are messed up. And here you can't return the same graph. So here you have this graph and this graph, both are same graph, but then this one is the copy. Here you can see the change of colors. Here you can see 1, 2, 3, 4. This is the original color, and here you see the original and the clone one is having the same color, so it is not allowed. So 1, 2, 3, 4, it looks like a copy. So we need to have just a carbon copy, but programmatically. So now input adjacency list, you have 2, 4, 1, 3, 2, 4, 1, 3. Now this is your adjacency list. It is array of array, like you have a nested array, 2D array, you can see. Of course, this is your one-dimensional array, and then this is your two-dimensional array, like you have opening and closing array here. So output should be the same, 2, 4, 1, 3, 2, 4, 1, 3. So there are 4 nodes in the graph. First node value is 1 neighbor, and second value is second, and fourth node value is fourth. So first, second, fourth node value is fourth. And then of course you have in the same way order. So here you can see you cannot have original same, you need to have a cloned one as it is. And then example 2, adjacency list, you have only one element. So explanation, note that the input contains one empty list. The graph consists of only one node value with equals to 1 and it does not have any neighbors. So in the same way, adjacency list, there is an empty graph, it does not have any nodes. So these are your test cases. So no matter all the test cases are getting passed, although the time is not very great when I'm doing the coding, but then of course we are able to find the solution. Of course, there are multiple approaches for this also. So again, once you try solving this, you'll get an idea. You cannot have same one. You can see this and this both are same, not allowed. This one and this one are different. You can see the colors of the vertices, but then this is for your visual representation. Of course, this is adjacency list only, but then how you see it visually. So now this one and this one, the colors are different, and of course, it looks like the copy. So this is how I can explain it to you. Again, I would recommend that you first go with some easy DSA questions like and medium DSA questions, because graph is a hard topic. Like I'll not lie to you, tree and graph nonlinears are comparatively hard. So should we go to another question or should we go with another topic? Because if you find like this topic is getting hard, should we switch the topic or should we continue here? Firdos code is also good, and you can see my code also. Here's okay, Aisha. This is the code. Because even if you see, there is no easy topic here. There are always hard topics and medium topics. Okay, fine. So now let's go with another question. And then cheapest flight within K stops 787. So you have to find the cheapest price of the flight. So see, there are n cities connected by some number of flights. You are given an array flights where flights of I, this is your first array, is from to price. Indicates that there is a flight from city to city and the cost price. You're also given three integers, source, destination, and k. Return the cheapest price from source to destination. With at most k stops, there is no such route, return -1. If there is no such route, you just return -1. So basically, if you have n is equals to 4 and flights is equals to 0, like it's a 2D array, 100 and 1 to 200 and 2 0 100. 130 100. Source is equals to 0, destination is equals to 3, and k is equals to 1. Explanation: the graph is shown above. The optimal path, what with an most one stop from city 0 to 3, is marked in red and has cost 100 plus 600 700. So you can see 100 plus 600 700. That's the optimum cost, highest cost. Note that the path through the cities 0 1 2 and 3. So these are your cities 0 1 2 and 3. Is cheaper but is invalid because it uses two stops. So you can at most have only one stop, I guess. The question is telling city 0 to 3. From 0 to 3, you can have one stop max. And of course, you need to find the cheapest flight. So here you cannot go. Maybe here you can go from 0 to, no, you cannot go. You need to go this way only. Or maybe try to find the solution. You can have at most one stop. Example 2 is also there. Example 3 is also there. Your conditions are given, constraints are given. Try to find the solution. Even I'll try to find the solution. I also don't know the solution as of now. Fine. So this is your question. Take your time to find the solution. It just to hint, it will need priority queue as well, PQ if you remember. PQ, when we were studying collection framework, smallest will always come first. Like if you remember, how many of you remember priority queue? PQ was a concept we studied in collection. If you remember, tell yes. If you don't remember, tell no. It's fine. I'm pretty sure we studied priority queue. If you want, I can show you the hint again. Should I open collection framework again? Should I open the PPT again? Again, I have given the PPT also to you. I uploaded it on GitHub only. Smallest will be at the front, largest will be at the last. Priority queue. So it will use priority queue behind the scene. Try to find the solution. If you are able to do it without priority queue, it's your choice. But I would suggest that you can use PQ here. Okay, so last 5 minutes, if you are able to do well and fine. If not, we'll do it together. You can see the type of inputs it's taking. These are already predefined for you all. You need to use priority queue and again use java.util.star so that you import everything instead of just list and hash set and priority queue and all. Array list, you can go import with java.util.star. It will get all the utilities. Okay, so now, did anyone find a solution, or should we do it together? Okay, students, so attendance time first. Go with the attendance. I give you 5 minutes of time to fill up the attendance. Then we'll start the solution ourselves. Okay? Please go with the attendance first. Okay, so now let's try to find the solution together. First things first, we'll be needing few inbuilt utilities. So I'll be writing import java.util.star, and it will import all the utilities that will be needed, maybe a hash map or a priority queue or anything. So we are already given an integer and then a 2D array of flight, integer source, integer distance, and integer k. K means, I guess, the number of stops. Yeah, k is equals to, it should be 1 only. Fine. So now we'll keep a map wherein we'll be using key value pairs, integer, and a list of int array. Close this, close the map. We will call it a graph equals to new hash map. And since we have taken everything as import, we don't need to import map, we don't need to import hash map. Everything is imported automatically. So now let's go for a for loop for integer array. I'll call it f for flights. And in the enhanced for loop, we'll write graph.compute. If absent flight from 0 index to x, a lambda expression. So I don't need to use an object. Again, this is lambda expression. It is used mostly with functional interface. Functional interface is an interface that returns only one abstract method. Abstract methods are the methods that don't have any body of their own. So you have like abstract method and interfaces. So interfaces, abstract methods are the methods that don't have any body of their own, and functional interface is an interface that has only one abstract method. So now we'll be using array list. So until here we are done. And then we'll be using a method chaining dot add new integer array. So my flight from one index array to flight to destination, from source to destination. So we have it here. So now flight part is taken care of. Now we need to take care of the other part, source, destination, and stops. K stops. So I'll write here source, destination, and stops. So I'll be using priority queue. PQ means it will always give preference to the smallest. Int, okay, it's int. It's a primitive data type, so I cannot write in capital. If it was a class, here we are writing integer because it's a wrapper class, and this is int. It's a primitive data type. So I'll call it PQ. And I'll create an object out of it. New priority queue. So we'll again go with the lambda expression a comma b, and this one should system.out.println. Instead of that, I am writing a short a index 0 minus b index 0. So pq dot offer, and here what we are going to offer. So Sheikh Nisar, please see the chat box. Amar sir has shared already the attendance link twice. So pq dot offer, and new integer 0 index. So we have source, flight, distance, and stops. All these things are there as our parameters. We need to use them as arguments. So we have used integer here already. So now the remaining three things would be from 0 stops till source, if possible from maximum 1 stop, or else go with the 0 stop. So here we come and tell integer stops is equals to new integer of n. So arrays dot fill, you fill it with stops and integer dot max value. And again, we need to write max value in capital because it's a final variable. So if it's final, we write it with the caps. So now while not PQ is empty, if the PQ is not empty, at that time what you do is integer array of current is equals to PQ dot poll. Poll offer will see, poll will add int cost is equals to, it's going to be cost is equals to, we need to see current of 0 index, int city is equals to current of first index, and int step is equals to maybe number of stops is equals to current of 2 index. Okay, and a semicolon, of course. So now if city is equals to cost, okay, destination, again these are given here on top. At that time you return the cost. Because we are more concerned into the cost part. I guess it will need some additional conditioning, but let's try to run this and see. Is it passing any test cases as of now? Okay. Okay, fine. It's not passing any test cases because we have said PQ dot offer and then it's not dealing with all the cases only. So now after we return the if step is greater than k or stops are greater than k or step is greater than stop k stop stop of city index, and I believe since it's logical, or this one should end here. You continue. If you don't meet the conditions, continue. And then you stop. So I should call it stops. Stops of city is equals to step. The number of steps you are taking. Again, we'll have to check the graph. If not, graph dot contains key of city. Again, it's telling us to return -1. It was telling us here somewhere. If you don't find the cheapest route, you return -1. You continue. And last, an enhanced for loop for int array of nei graph dot get, and what we are going to get city int next city is equals to nei. Nei is a variable of 0. Int price is equals to nei of 1. Semicolon again. I do forget semicolons. So now priority queue dot offer. Now priority queue should return us something. New integer and cost plus price next city and then step plus 1. If these are all the criteria that are met, you do in the offer and return it, or else you just return -1. If it works, works. If it doesn't work, don't worry, just return -1. So now let's try to see first our code. Are we going in the right path or not? So for int array f of flights, okay, graph dot compute if absent f of 0 lambda expression new array list, okay, dot add find f of 1 and f of 2. Okay, let's remove space from here. Source destination stops, okay, again a lambda max value taken. If not, pq is empty, fine. Okay, it's int not inst, my bad. Okay, destination, okay, fine, looks okay. As of now it looks okay. Let's try to run it and see. And it says compile time error. Fine, pq, fine. It says on line number 14 it has found an error. And let me see what can be the possible error here. New int And let's try to again. What is the error here now? Anyone any idea? Yeah, maybe I don't need to put a index number 0. That was the error. Accepted, fine. Expected 700 result. So we will be going 700 is the cost. We cannot do anything because we have to take only one stop. Let's try to submit it and see. Yeah. So you can see it has worked. The error that was there was I was putting hard coding array of 0. We just need to take an integer array. No need to put any value. So if you want, you can take the screenshot of this solution. Again, this is not the optimized. You can see people have much better solutions here. That ran in 6 milliseconds. For me, it ran in 8 milliseconds. So you can see the time complexity. But I'm happy it ran at least. So I'm pretty sure if we try to take one more question, we will not be able to complete it because we just have only 8 minutes left. So now we'll be going through some theory part. Anyone any doubts in this? Any doubts? Fine. So now fine. So now let's go with some theory part only because I believe that is going to be more important. The agentic AI, no, this is not there. The collection framework that was pushed on Git. This is also not there. Graph DSA. Okay, this is what we wrote just now. So here you can see for DSA lead code, I do have something, I guess. So these are the questions. And if needed, even if we to solve these questions, believe me, it's sufficient. But I would request you all, first you go with the easy ones, then you go with the hard ones. So I'm copying this and pasting it in chat box. But first you make sure that you go with the easy ones and then you go with the hard ones. Again, if needed, we'll be doing this from tomorrow. So here you can see for tree and graph. Okay, this is what we did. So this is your 8-week lead code challenge. Prefix to some pointer. It has DSA question numbers as well. So it will teach you all the concepts that are needed for your DSA, but it takes a disciplined 8 week. Again, this note I'll share with you. And from tomorrow, you will tell me what all we need to do. So we'll be doing that. Please save it because you keep on asking me for resources. And the more you code, the more you'll understand. So you have theory plus practical. Now this is something that has theory as well as practical. Do you want these notes also? Searching, sorting, everything is there. Binary search, jump search, exponential search. Okay, fine. With time and space complexity. Okay, so let me copy this and paste this one also. I guess there was only one yes, so I'll give that to one yes. So you have DSA all pattern questions. Star Technologies, the attendance is already taken, my friend. So fine, from tomorrow, you will tell me what all we need to do and then we'll go accordingly. I've already shared some resources with you. Again, you have longest substring with without repeating characters. So these are all the questions along with the answer. If you keep on coding, of course, you'll keep on learning. The only shortcut to learn is to keep coding. Arrays, what are arrays, pointers. So a lot of resources are there. But again, the question is how much are you coding yourself? What is a linked list? Sliding window. Fruits into basket. Binary search. It is also called divide and conquer. Fine, so anyone any doubts? If you don't have any doubts, I guess we can end the session. Anyone any doubts? Except for attendance, please. Attendance is not a doubt. So I've shared the notes with you also. If needed, tomorrow also you can practice, and we have 8 weeks lead code challenge and DSA lead code PDF. Fine, so we can end the session. Thank you everyone for your presence. If you have any doubts, you can ask me or else we can end the session. Thank you everyone. We can end the session. Thank you. Okay, Amar sir.
Yeah, thank you, sir.
Thank you. Thank you. Bye bye.